Hello my friend, the next chapter is about KNX bus devices. Now we want to focus more on the bus devices in KNX or based on KNX protocol, and also try to consider two practical programming in ETS by using the KNX virtual. Okay, so first of all, the book said that each KNX bus devices include three parts: application module, bus coupling unit, and the application program that is installed in application module or bus coupling unit. Of course, when these two parts wants to be connected to each other, it needs the physical external interface here. That it includes 10 pin, and in B4 we saw these devices so much. I mean, in B4 most of the keypad that are installed on a wall, they can be separated to the application module and bus coupling unit. These days barely we will see in a market these parts in separated parts, and we saw one device, but in fact this one device include these three parts. I mean, the application module, the bus coupling unit, and the program or application program that is installed on application module or bus coupling unit. And these two are connected to by means of physical external interface, PEI. But nowadays, as I said, it is vanished, and maybe there is no anymore using such a disconnection in the devices. But the book said why this physical external interface is used. Maybe in exam it's be questioned. This physical external interface is used to exchange message between both parts, application module and bus coupling unit. What it means? It means, okay, application module is in contact with the physical layer in our world. I mean, you, for example, by your hand push the application module, push the push button and send some comment. Okay, these comments should be transmitted by the means of physical external interface to the bus coupling unit. Then the second task of PEI or physical external interface is providing limited power to the application module. Okay, because from here the 21 to 30 volt DC is coming to bus coupling unit. Then from this physical external interface, this power is coming to application module, because it should be worked, it should be powered up to be able to send the message to the bus coupling unit and the KNX. The book said in a DIN rail mounted devices, the bus coupling unit and application module are usually inseparably connecting in one housing. But remember that nowadays also you can see these three parts, such a product. For example, the Delta keypad from the Siemens, or some previous family from the ABB keypad, they are still use this physical external interface to connect these both parts. And remember that when you want to ordering, you should order these separately. It is important. Okay, another point in a book, it says that in B4, in early days, a bus coupling unit could detect whether the application module is stuck on it, whether matched or not. It means, for example, you have the bus coupling unit from the Siemens, okay, and the application module from the ABB. This bus coupling unit should detect whether this application module is suitable to be connected or not. Is it from Siemens or not, for example? Okay, so what's happening it used the resistor to detect it. How it's happened? According to the book, it says, by the measurement of a specific resistor of the application module over the physical external interface and comparing it to the physical external interface type of the loaded application program. In case of the mismatch, the loaded application program could be stopped. These days, manufacturers may use the mechanical coding to ensure that only the proper application module is stuck on the bus coupling unit manufacturers. Simply build integrated devices where such a check is not needed. Okay, so nowadays it's a bit different. In case of TP devices, the connection to the bus is mostly ensured via the standard bus connector. You have seen the bus connector black and red, so it is used to connect for most of the devices in KNX, more than 90%. Okay, so the next fact is inside an integrated KNX product there are something. An electric circuit, mostly chip, taking care of the coupling function to the respective medium. It means respective medium, it means like the TP, twisted pair, IP, or RF, responsible for the sending and receiving of the telegram, called transceiver, so we call it transceiver. A microcontroller running the system or operating software and application program. An electronic circuit taking care of the application function. Okay. So now the book is going to set one by one the task of these parts. In general, the transceiver and microcontroller are integrated in a regular bus coupling unit of which the electronic cannot be separated. In some rare cases, the transceiver is offered as a separate module. Okay, the transceiver module, we have it. I think in Siemens we have it still. Each bus device has its own intelligence. Own intelligence means microcontroller, thanks to the integrated operating system and program memory. This is a reason why KNX is a decentralized system and does not need any central supervising like server or computer. Central function supervision can, however, if needed, be realized via visualization and control software installed on a PC or tablet. For example, you install NetX automation on a PC, make it as a server, and connect it to the KNX system. That's it. It can communicate with server or center, but it's decentralized and there is no need for that. On a KNX product or the bus coupling unit, in most cases, a programming button or programming LED can be seen. Of course, we have seen this. The button is operated to put a bus coupling unit or product in programming mode. Yes, I know that. You know that also. Bus coupling units are currently available for connection of two different media. So when we talk about bus coupling unit, it means it's going to connection of two media, twisted pair and RF. Okay. Remember that in KNX or in any other BMS devices, totally as a hardware we have the sensor, actuator and controller. So you can divide these type of devices, okay? But nowadays it is rare to see in a market these separately, okay? So in most cases they are merged together. So what it means? It means if you have a keypad on a wall, it is a sensor, because it collects data from the physical layer in a room. And it transmits the data to the bus KNX. But when you press the push button, there is teeny tiny LED on it, and it's received the status or feedback from the actuator or from the bus, and it's turned on. So it is actuator also. And in many cases, this keypad includes the logical function, so they have the controller. So you can see the device is a sensor in totally, but if you get deep inside to the device, it is also the actuator and controller. But in overview, it is a sensor. One possible function of the KNX sensor is to detect physical variables such as temperature, voltage, current. The application module of the sensor thus transfer information about its actual input, digital or analog, to the bus coupling unit. I said it before. The bus coupling unit codes this data and sends it to the bus. The bus coupling unit therefore regularly checks the state of the input of the application module. In case of an actuator, the bus coupling unit receives a telegram from the bus, decodes it, and passes the information onto the application module, which then will execute the commands such as switching and output. Yeah, so here in these two paragraphs, first of all, it says it received the physical data from the physical layer and transmitted to the bus. Here, the telegram or packet of data is coming from the bus. It turns to the physical action in the physical layer, or for example, close the relay. So these two is there is some definition between the sensor and actuator. And the controller regulates the interaction between the sensor and actuator, like the logic module, I said it, or the thermostat, for temperature, humidity, wind speed, and so on, and has no physical input and output. So controller, there is no physical input and output, everything is virtual in it. Okay, over the years, KNX and its manufacturers have standardized different versions of system software. This system software is like, for example, in Windows we have Windows 8, 10, and so on. So it's called system stack or KNX operating system. These different software profiles are identified towards the ETS by means of mask version. So if you press on a device in ETS, do the right click and get the info from the device, you can see the mask version. Also in individual address check, there is a line scan, and if you do the line scan, you can see the mask version. So the mask version or device descriptor type 0. The mask version consists of 2 bytes and cannot be changed in a device. So it means you never be able to change the operating system of the device. When downloading the device, the ETS checks this system software version to be able to make out how the device needs to be configured. Further information on this system profile is given in clause 62. So you should go for a KNX cookbook. Okay, temporary values of the system are stored in a RAM. Okay, so the system software is in a ROM, ROM, but temporary values are in a RAM or AM. These are lost when there is no power supply to the device. Yeah. For example, the last status of the switch, or the temperature that is read by the sensor. The application program, the individual address, group address, or parameters are stored in an EEPROM. Okay, EEPROM, it's the rewritable memory. Remember that. But this rewritable memory is not forever. There is some limitation how many times you can rewrite it. It's about, I think, 2,000 to 10,000 times. So we never reach the limitation in our life, but there are some limitation for EEPROM. Yeah. Okay, good. So now I think this information is something really nice. Next part, we go for a system profile. Okay, I mentioned that there are 3 system software, 3 times: system 1, system 2 and 7, system B devices. So nowadays the devices are manufactured with the latest system profile from the KNX or system stack. It's called system B. Yeah. But what are the differences? You can see the differences. In system 1 devices, okay, the maximum group addresses that are used is only 12. So imagine that for the EIB system in 1990, you could only define 12 group addresses. Then in system 2 and 7 it increased to 254, and nowadays it's more than 60,000 group addresses you can define in a project. That's nice. Then in system 1 devices, the interface object, KNX serial number and KNX access control bus coupling unit key is not supported, but nowadays it is supported. So now we are going to understand what are these interface object, serial number, or bus coupling unit key. But in the first row of this table you can see the example of the mask version. Okay, so whenever you see the 7B, it means this is a system B. Okay, or whenever you see the 70, it means system 7, or 02, it means system 2. Okay, or 01, it means system 1. The first 0 is represent the media. Is it, if it's 0, it's the twisted pair or other numbers for RF, power line, or IP. Great. Okay, so some important things here is written. I try to read it. Application programs designed for System 1 technology can also be downloaded into a certain System 2 devices. Upward compatibility. In KNX, we have the upward compatibility. System 2 application program can, however, not to be downloaded into System 1 devices. Okay, so the application program from System 1 can be uploaded to System 2, 2 can be uploaded to System 7, 7 can be uploaded to System B. Okay, this is a upward compatibility. It means in future, if some new ETS is coming, okay, and new system new system devices will come, it can understand the previous one. Another important thing is the actual number of available group objects or group addresses which can be assigned to the device depends on the used microcontroller. So remember that. Okay, so now we are going to understand what is the access control, what is the serial number, and what is the interface object. You can see here it says support access control. So when a tool wants to access memory of the device 27B, reading or writing, it must first authorize itself by means of authorization key of 4 bytes. Okay, so what is this key? Keys can be defined at various levels. Some of the levels are reserved for the manufacturer access and can hence not to be accessed by the system integrator. One level, however, give access to not system related memory in the device and can be locked by entering a bus coupling unit key in the project properties. Devices that have been locked by means of bus coupling unit key can still transmit telegrams. Only re-downloading a locked device without the proper bus coupling unit is not possible. Okay, bus coupling unit key are used in the ETS project. For this reason, it is vital to properly back up ETS project. So what it means, it's nice. Here, for example, I have the project, last section project. This is topology project. One click on it. From right hand side, you can see behind the detail there is a password and bus coupling unit key. First of all, you should define a password. Okay, it needs dongle. Yeah. Okay, first of all, you should assign a password for the project. For example, 1234. And 1234. This is for project. You should make it. That's it. Then you can assign a bus coupling unit key in hexadecimal format. Okay, I put the set key. For example, I have some hexadecimal format, 1B, 1C, for example, and then click OK. That's it. And this is a coding time of these devices. If I'm going to download the application into the device for this project, okay? Now, when I set it, I come here and download it, huh? If I do the download the device, application download, from now on, the people or the third party cannot re-download it or unload this device anymore. Otherwise, they have this key. They should have this key, 1B, 1C, for example, okay? This is important. And if you lost this key, mostly you should send back the device to the factory. Of course, for some devices, there are some rules to make a shortcut in a board and reset this password, but mostly you should send it back. If the product equipped with this password, still it is possible to send and receive the data. I mean the telegram or packet of data, but you cannot download or unload it anymore. So my recommendation for you is to use this password. It's really nice. Use it. But not in a classroom and not for the test, but in real project you use it and always make the backup from the ETS project and save this password, because if you lost it, it will be a big problem. The next capability is KNX serial number. So what is the KNX serial number? It is interesting also. For system 2, 7 and B, the KNX serial number, it means it is assigned to each device before leaving the factory, allows writing or reading the individual address of a device without having to press the programming button. So it means you can use it to assign the physical address from the ETS without press the programming button. But nowadays I saw only one manufacturer, Siemens, with the KNX app in the ETS, you can use it and not go to press the program button and use the serial number. But other manufacturers, you should push the programming button. But fundamentally, for all the devices, this possibility is provided by the system software. Anyway, and about the interface object. So what is the interface object? Interface object contains certain system and application properties like the address table, parameter, and so on, which can be read or write by the tool with the ETS during the download without explicit knowledge of the device memory structure. The ETS end user, like the system integrator, cannot manipulate such an interface object but can read them by means of ETS device editor app. So what it means? It means nowadays, if you have the dongle light version or professional version, you can use the device editor app and read the memory. Just read the memory. You cannot write on it, You cannot change it because you are not manufacturer. But you can read it in hexadecimal format, I think, or something like this. And then you should translate it and understand in depth the system knowledge. So it's nice. It's nice. During the KNX tutor courses, we will cover it. And about the memory size, I mentioned you about in B4 only you are able to define 12 group addresses, but now there's more than 60,000 group addresses you can make it. So the point is, in B4 the memory size was eliminated, was not, and after that, because of the market needs, the project needs, and the hardware the hardware prices are not so much nowadays, so the memory size are increased or have been increased, better to say, and nowadays you can have more than 60,000 group addresses in the devices. Yeah, great. So now we are going to understand and see what is the dimmer and how we should program it in KNX. Nice. Okay, when we talk about the dim, what it means? It means you can use the KNX communication, KNX telegrams, to dim up and down the lights. You can see in a movie what it means. Look at this lady. It's used the phone to decrease amount of light. Okay, great. So now we are going to see what are the facts in KNX about the dimmer. First of all, I want to tell you about something that during the basic course we follow the phase dimmer. I mean, we use the dimmer actuator from the KNX devices to dim the 230 volt AC lamp. Okay, there are other useful and very professional type of dimmer in technical, like 1 to 10 volt DC ballast or dolly ballast or DMX, and RGB or RGBW, which is used 12 to 24 volt DC as an output. So all of them we are covering in advanced course. Okay, so in basic course we tell you about the fundamental of dimming function. Okay, and then also we do the test in real by the 230 volt phase dimmer. Yeah. Okay, so how the dimmer, standard dimmer, work in KNX? This is the figure of how it's working. We have short operation and long operation in KNX. It means there is a push button and there is a dimmer. You should press the push button to dim the lights and or decrease the dimming. So if you put your hand on a push button as a long operation, for example more than 1 second or 2 seconds, it is increase the amount of dim. If you pick up your hand, then the dimming stopped. Okay, for example in 70%, for example, and in case of time t, in second, of course, it remains the amount of light. If you do the short operation, it's turned to off, and if you do the short operation again, it's turned to on to the last brightness value, or if you choose something else to do 100% in parameterization of the device, of the actuator, it's turned to 100. And if you do the short operation again, it decreases. Okay, so you can see increase by long operation, short operation decrease, short operation turn it on, turn it off, and turn it on again. With long operation is decrease. So this is the standard type of the things that I want to say about the dimming in KNX. Of course we have the hold and release or other things. It depends on the manufacturer. Then in a book it is written to you something interesting inside of the phase dimmer. So we can see the inside of the phase dimmer. It is interesting. Let me provide you some nice fact about it. Okay, so from here the device is connected to the KNX. Okay, this is a bus coupling unit, and this is the application module of a device, and this is a dimming electronic ballast. Okay, so whole of this, it's called dimming actuator. Okay, in a dimming actuator you can see there is a relay, on-off relay, and digital analog converter. So how it works? The 230 volt from the utility in electrical cabinet, it's coming to the relay, okay? And the relay is going to supply the dimming electronic ballast. But this electronic ballast needs a signal to control. This is a 1 to 10 volt signal, and this 1 to 10 volt signal is coming from the digital analog converter that is located in application module. Okay, great. So the packet of data or telegram from the KNX bus is coming to bus coupling unit, is handled here. From here the relay will be closed. Okay, and for example you want to dim it to 50%. Okay, you want to dim it to 50%. The outside of digital analog converter will be 5 volts, and this ballast is going to make it 50%. Okay, great. So for programming, what's happening? For programming, I want to control this relay, so I need one group address, and this group address is going to switch this relay. Okay, and I want to control this digital analog converter. I need the second group address. So at least for operation I need one group address to make it on, and one group address to control this digital analog converter. This group address can be 4-bit. Okay, can be 4-bit. Let's show you 4-bit. It's called relative dimming. Okay, it means it is increased relatively step by step or decreased relatively, and it can be 1 byte. It is called absolute dimming. Absolute dimming, it means you can, for example, tell the light to go to 50%, 10%. Okay, it is not relatively. It is going to change the amount of light in absolute way. Okay, of course we have some other group addresses to transmit the amount of light and show it in a LCD. For example, if I turn it to 50%, I want to know the 50% on a movie, on a mobile phone. This light level will be transmitted. Great. So now you understand two things. First of all, the operation standard of the dimmer. Second, the inside of the dimmer. So you see this group address 1 and group address 2. This group address 1, it's going to use for short operation. Okay, and this group address 2 is going to use for long operation. Remember that I said the short operation, switch the light on off or on to the last brightness off forever, and the light, the long operation is going to increase or decrease. So it is in two ways, relatively or in absolute way. Great. So now I'm going to provide some example in ETS. Okay. See. Okay. This is the ETS. I provide some new project. It's called Dim in Virtual. Okay, Dim in Virtual, nice name. Okay. I go to the device page because I want to be very fast. Add the devices, and from here in catalog I choose the KNX association because all the KNX virtual devices are existing KNX association. From the KNX association I'm going to add the dimmer. Drag and drop. And add the clicks. So I add the dimmer as actuator, add the clicks as a sensor. Okay, great. I don't need catalog anymore. I close it. So the dimmer, I assign the physical address 1.1.2, for example, and the clicks 1.1.10, for example. Okay, great. Okay. Okay. So now I'm going to do the parameterization. In dimming, I want to use the channel 1. Channel 1, in KNX Virtual is really easy, but to start is a good idea. So dimming speed is slow or fast. You want to do it fast or slow? I prefer slow because it can show it yourself. You can show it how the dimmer is working in a building. The artificial sense is much better. The dimming steps is resolution. It is 8 steps, 16 steps. Okay, I changed to 16. Feedback, yes, I need feedback. I want to have the feedback. Info, enough feedback and info dimming value. I put both of them. It is optional, okay? It is optional, but I put both of them. And alarm, no, I don't want to interfere with any alarm. In clicks, I want to do it the dimmer with channel 1 of the keypad, okay? Channel 1, it means the row 1 of the keypad. I select it. I change the function to the dimmer with 8-bit feedback. Great. The dimming is step 16. Nice. It's nice. Yeah? Okay. So now I'm going to see what group addresses are made. Here for channel 1, enough. Yeah, 1 bit enough, 4 bit. It's called dimming control, but it's relative dimming. Okay, dimming value, it means absolute dimming. Info enough, and info dimming value. It's really complete one. We don't need all of them. It's a complete one. In clicks, or I can say, yeah, I need the dimming enough, dimming control, and feedback dimming value. Okay. Now I'm going to open the group address to make the link. Okay, the main group address is floor, for example, number 2, yes, it's nice. Then here I add the functionality, dimming, or light dimming, yes. And in light dimming, I add something. Okay, control, switch, on off. LD means dimming, okay? LD, for example, channel 1, okay? This is 1 bit. Then control, relative dimming, for example, this is 4 bits. As an optional, because I want to show you how to change it from the PC, I say absolute dimming, okay? And also I can say status light level in percentage, okay? So, but in KNX Visual you can only see the color, yeah, it's not percentage. I can show you, I hope it works in group address, okay? Also we can have the status as an optional also, optional, I say optional, status, switch on off, it is possible also, okay? So I'm going to drag and drop. So from the keypad, from the actuator, with this group address we can make it run. For relative, I use the dimming control. In clicks also dimming control. This is 4-bit by 4-bit. The size must be same. For absolute one, because I don't have anything in keypad or clicks from the KNX, I only use the dimming value absolute one here because I want to send the comment from the PC. As a status light level, you can see from the actuator I have the info dimming value. This is the light level, and from the clicks I have the feedback with dimming value 1 byte by 1 byte. Okay, and for on-off feedback from the actuator I have the info on-off. But it doesn't necessary at all. I just put it, maybe in some cases you need it, maybe in some cases. So now it is ready to download. Click right, do the full download. Okay, come to here in KNX Virtual, device topology, device 0. Okay, I download it. And the next device is device number 4. I do the full download. Yes. Great. Both of them are downloaded. I come to the view. You see this D4, the clicks, it's changed here. I click here in the up, dimming up. Okay, it remains from the previous example. Okay, I delete it. So now I do the short operation. Okay, here I do the short operation on, short operation off. In real, you can send it to the last brightness value. So here I do the, I can say, you see, it's a long operation. Okay, if I click it, it's a long operation. I can increase it or decrease it. Do the short operation, off, on, last brightness, off, on. Okay, long operation, off, on, again long operation, upside. Yes, so it works, increase and decrease in relative way. Okay, and I hope it works. We can send the comment from the ETS. How we can do that? Because we make the group address diagnostics, we activate it, start, select the group address, absolute dimming, you remember that. I want to change the dimmer from 43, for example. Let's have this because I want to show you. Yes, from 43, for example, I want to go to 20%. Then press right. Yeah, it's go to 20%. It works. Or 80%. 80. So from the PC, you can send a comment. Of course, for example, to the 1 byte value. Okay. Great. Okay, so now we can go for a shutter or blind actuator and see how it works in ETS. Okay, so imagine we want to move the shutter by means of using the keypad. Okay, like this. We want to push the keypad to lower down the shutter. So this is of course the up upside down, downside the shutter. We have another type that is move the shutter from the left to right. The control is almost the same. So how we can understand it? Let's see. First of all, in shutter also we have the short time, short operation and long operation. Okay, in a blind with a slat, I mean the shutter with a slat, we call it blind. We have two type of operation. First operation is moving the slat to let, you can see it in the movie, to let the light come inside of the room, okay, or bend the light. And we have up and up, downside movement. So there is two movement, okay. There is two movement. You can see it. One is control the slat. One is upside and downside. Okay, great. So, two time of the long operation is described in the shutter control. If you do the short operation, you stop the motor. Okay, so for example, the shutter is going up or going down. You push the push button for less than, for example, 1 second, less than half a second, and it stop. But if you hold it for T1, okay, for T1 or less than T1, you can move the slat. And if you do the long operation until T2, you can move the blind up or down. Okay, so this T1 and T2 is used to describe you how you should operate with the push button in a standard way to control the blind with a slat. Okay, so as I said, there is two type of the movement, upside and downside. One upside and downside is like the roller shutter. It's only go up and down. And there is another type. It has a slat. We called it Venetian blind. Okay, so in Venetian blind, in long operation, there is two operation. So if you do the short operation, it stop. If you do a bit more than short operation, lower than longer operation, you move the slats, as the book said. And if you do the long operation, you can move the blind up and down. But remember that for this two type of the operation, you only use one motor, one tubular motor, okay? This tubular motor in blind with a slat should support the step move. It means when you power it up with 230 volt AC, it doesn't round for 360. It's round, for example, some degree, like 30 degree, okay? Because then with a small movement of the motor, you can move the slats. Okay, so, and the book said about inside of the shutter actuator, okay, or blind actuator. They are the same almost. Let's see how interesting it is. We want one group address, okay, group address number 1, to move. It is used for long operation. Move what? With this group address, if it is 1 or 0. If it is 1, it energizes this S1 relay, and for sure this one is not closed, it is open, and vice versa. So it is applied here as an interlock operation. So if the S1 is closed, S2 for sure is open, and if the S2 is closed, S1 is open. Okay. At the same time, these two are not closed at all, because if you power up the motor, AC motor of the curtain, of the shutter or curtain or blind, it will be burned. you will lose the motor. Okay, one group address is for this, and group address number 2 is used for stop. It's for short operation. Okay, if you press stop, for sure the S1 and S2 is open. No, they are not closed anymore. Also, this group address for blind actuator is used for step movement. As I said, your motor also should support step. This is for step movement. Okay, so it can support to power up the shutter motor or blind motor for a second. Great. Now we can go to a ETS, but before that you can see the group addresses here. Here also in group addresses that the book prepare for you, there is some object for safety. Later in advanced course, when we are going to cover the chapter safe planning, we will cover it because it needs to show you the operation of the weather station, and then how the wind speed can affect the outside shutter in a building, and what is the safe plan for that. We can use safe operation over there. Great. Now we are going to the ETS. The new project is shutter. Great. Shutter 4 test. Okay. We go for devices. Add the devices. Find the KNX association. Okay. And find the blind control. Yes. Drag and drop the blind control here. And clicks. Close it. Do the physical address 1.1.10 for clicks. Okay. And the blind actuator 1.1.3. After that, we should go for a parameterization. In a parameterization, I check highlight, channel 1. Okay, in channel 1, it asks us if we want to start some specific operation. I only place info position because I want to know the status of the actuator. Here in clicks, I want to tell the channel 1 what to do. It is better to have the blind with feedback. Okay, and that's it. So let's look at group objects. Here I have move, I have step, stop. You remember I told you these group objects work in two ways. And then we have the position and info position. Position is like the here. It's like the absolute dimming. This is absolute position. You can send the shutter to a specific place, okay? And this is the info position. This is a feedback, okay? In clicks, we have move, we have step, stop, and we have the feedback. Okay, great. Now I'm going to provide group addresses, okay? Add main group address. This is floor number 2. For example, the middle one is blind. and group address. Okay, so this is control move S, for example, BL channel 1, then control stop, then control position. I want to show you the position because I want to control it from the PC, and this is a status position or feedback position, or the KNX Virtual is called info. Okay, so in control position I make the link between the sensor and actuator, 1 bit with 1 bit. Stop also, drag and drop. Also there is another way. You can come to the object, right click, click link with, okay, so then you can link it. Okay, I'm not sure what is this. This is control feedback 1 byte, so it is linked with status position. Okay, it is linked. Now in a blind actuator you can do it from here, position, yes, okay, and info position, yes, okay, that's it. Now we can go to a download, but before download I want to show you reset factory or unload also. Now it is good for you, unload, use the unload devices, then we can come here, go for device topology, use the unload device. For example, I want to unload D0, press the program button, it is unloaded successfully. Okay, I want to unload also, for example, D3. You see, when it's unloaded, the physical address is turned to 15.15.255. Okay. Okay. Okay, now we do the full download of the blind control and clicks or push button. Do the full download. Oh, okay, great. D2. This is D2. Do the full download. And D4 is for clicks. Okay. Now we can go to the base and see how it works. Okay, you can see if I push this one as a long operation, it's coming. And if I do not push it anymore, it's continue to the end. I push it once, it stop. Okay. Also, it's because it is a stop step, it is responsible for more than short operation, lower than long operation. So you can see for one click it works like this. It is here in KNX Virtual cannot represent it very well, but this is the step move. Okay, you can see this is a step move. Also, I want to show you what we can do in diagnostics here. We can select the position of the shutter. Okay, you can say the position of the shutter. You can see it here. Now let's try if it works. For example, I want to go to the 20%. It should be go up to the 20%. Yes, it works. Yeah, great. Or for example, 95%. It should go down. So you can see with a nice resolution, you can control the blinds. Yeah, great. Thank you so much for listening to me. This is the another chapter of the book, Boss, with 2 practical examples using the KNX Virtual. I hope you enjoy it, and I will see you in the next chapter. I think there would be not so much to finish the course. In next chapter we will going to cover the installation and some more practical things. Thank you so much. Have a nice day. Thank you. Bye bye.